Hello friends, we are solving the third problem of Leetcode contest, split and merge array transformation. So we are given two integer array nums1 and nums2, and both of them have same length n, and we have to perform the below operations. So we can choose a subarray starting from L and R. So L and R is any start point and end point integer of that array. So we can choose a subarray. Now remove that subarray, so there would be a prefix and suffix right out of that. So for example, you can visualize like this. So suppose this is our nums2 and this is our nums1. So what we have to do is we have to do those operations, replace and merge, right? We have to do that operation, and with that operation we have to make this nums1 should equal to nums2. So for example, let's say this is 3 6. Okay, so if I make a cut here, if I remove 3 and 6 here, what would be the left part and right part? The left would be 1 2 and right part would be obviously 4 and 5, right? So if I make this 3 6 cut here, it will give me like this. It will give 1 2 4 5 like this, 1 2 4 5. So this is the left part, this is the left part, and this is the right part. After removing this 3 6 from here, we had the 3 6 here, right? So we removed it. So left and right part is like this. Now this 3 6 we can put anywhere. So let's say I'm putting this 3 6 at the end, right? So in this one operation we have found here, right? We reached till here. Now we will check that, hey, is it equal to nums2? Okay, this is 1, this is 2, but this is 4 here, but here it is 5. So we have to it's not equal. So then again we have to make a cut somewhere, and then we have to again do that. So for example, let's say this time I'm making a cut here. We are making a cut here. So what would be, if I remove this, what would be the left and right part? Left and right part would be like this, 1 2 5 3 6, right? This we have removed. Now we can put this 5 wherever it is required. So what if I put my 5 here, this 4 here, right? So 1 2 5 4 3 6. Now this would be the new array. So now this time it is equal to 1 2 5 4 3 6. This is equal. So just in two operations we are able to make this equal to nums2, right? So this is what we have to do. Okay, so what we have to do, we can make a cut of any length in nums1, and then that length we can put it anywhere after removing it. And in that case, how many operations it would be take to make the nums1 equal to nums2? Like in this case, we in the first step we removed the 3 6, and then we make a cut on 4, and then finally we have got this, and we are free to put the cut anywhere, including in between somewhere, or at very first location or very last location as well. So this is what we have to do. Now next thing is how to do that. So before going to that, we should look at the constraints of the question. So you guys can see here the length of nums1 or nums2 would be only up to 6, starting from 2 till 6. So that means length is not going very huge, just 6. That means even if we go in brute force approach, it should work smoothly. Okay, so we have to always look into the constraints, which gives us some indication. Okay, now what we're gonna do here is same approach we would be using in the BFS manner. Why I'm calling BFS? Because we don't know that what would be the length of cut, and we don't know where should be put, right? No grid is going here. So what we can do is, because numbers are not very huge, so we can use the greedy approach, BFS approach here. Okay, so what does it mean is BFS in the sense, whenever we are operating on this nums1, okay, we are finding the minimum number of it. So we may take any position here, right? We can start that we are making a cut here only, or we are making the cut here only, or we are making the cut. So all the lengths we would be try. Okay, so once we would be removing a length whenever we are making a cut starting from any L and R like this, then we would be having the left part and the right part of it. Let's say we are removing this 2 3 6, then left part is 1 and right part is 4 5. So we would be having a new list kind of 1 4 5. Now we can add this 2 3 6 any place, at the front, at the end, or anywhere in between, right? So there would be multiple in one step we can find the multiple positions. 2 3 6 can be put anywhere. So here we get an indication that once we have got a cut, we can put it anywhere, front, back, anywhere, right? So this approach we can do one by one for the BFS manner. How I can say this would be a BFS manner? We would be creating an this queue. We would create a queue, and whatever possible, what all possibility we are making, we are putting those things into that queue. Okay, and then we will increase the step, and we will check that, hey, is there any possibility that we have found the nums2? So in that way we would be doing. For example, let's say here we might make a cut here, or we make a 2 3 or 3 6 anywhere. So then we would be putting it. So in the one step, whatever new strings, whatever new list is becoming, we will put them into this list. Okay, and we will increase our step by 1. Okay, so and now we will check whenever we will pop out a string from it, we will check that, hey, is it equal to nums2? If it is not equal to nums2, we will again operate the same thing, again make the cut. And one more thing is, we will keep a set. So what this set would be, the set of the list. Why do we need it? So whenever we are popping out a list out of it, if it is already seen in the set, then we don't have to proceed it. We will be check only those which are not yet seen. Okay, so in this way we can find, and every time we would be increasing our step, and the time at which we will find a list which is coming out of this queue, and if it is equal to nums2, at that time we will return whatever number of steps are done. So let me write the code which would be making a better sense here. So let's go here. This is our code here. Let me write, we will write together. So first of all, what we will do is nums1 and nums2 list. Let's quickly convert them into list, right? Why I am converting them into list? Because in the list we have the lot of methods where we can get it directly sub list, but in an array we cannot get the sub array kind of thing. So for that reason I am doing. So let's say we are calling it target. So list target would be, it would be our nums2, right? So new array list, we can write in new array list of like this we can do. And what we will do is, we will be putting all the values of nums1. So yeah, nums2. So we will put them into, or we will add them into target. So we will do target dot add whatever x we are getting. So here we have changed the nums2 into target. Let us do source as well. Okay, so what we gonna do here is, we will make this as nums1, and we will call this guy, we will make one more list which would be called source, target and source. So we are starting from source, right? So let me make it source here, and this would be our nums1. So we are adding everything into this source. So very first what we have done, we have converted both the nums1 and nums2 into corresponding array list. Okay, now what we gonna do here is, we would be making the this one queue, right? So how do we do that? We can do it queue. Let's say we are making it dequeue. So dequeue of the list of integers, right? We have the list of integers. Dequeue of the list of integer, I am calling it queue, is equal to new dequeue like this. Okay, so we are done. Now we will create a list, a set also. So this set would be of array list set. So let me make this set of array list like this, and we will call it, let's say we are calling it set equal to new has set like this. So we are done with these data things. Now first of all, what we will do is, very first time what we're gonna do is, initially in the queue we would be adding entire source, right? Because first time we are coming and our step is also 0. So let's add this queue, this into the set. So queue dot add whatever value we have. So we will add this source, right? So I'm adding this source here, and also because we have added it into the queue, we would be adding it into the set also, because anyway initially we are putting the entire nums1 into the queue, and let's make it seen in the set also. So set dot add and source. So we have added it. Now what we're gonna do is, we would be traversing through this dequeue, right? So while not queue dot is empty, so till the time it is not empty, we are popping out the things. So first of all, what we're gonna do here is, we would be making the size. So we will take the size, int size equal to q dot size. Why I'm taking this size is because there could be every time we are taking the entire size for that steps. Okay, so initially let me put here int step equal to 0. Okay, so we are making this size equal to q dot size. Now we will use a for loop. Okay, so for int I equal to 0 to I less than size and I plus plus. So what we're gonna do here is now we will pop out the elements. So for example, list of integer, let's say we are calling it al, we are taking it from the q. So q dot is that Paul? I think yes, that should be the Paul. So we are removing it from the front of it. Now what we would doing this al we have got. Now what we will be doing, we will make the cut. Now this cut could be L and R, right? So L could be starting from 0, right? L could go from starting from 0 till end, right? Till L equal to n minus 1, whatever is the length minus 1, right? So it can go up to that level. So what we gonna do here is we will be using for loop. So for int L equal to 0 till L is less than whatever is the n is the length of it. So let's say we are also making here n, so we can do that. Let me write it int n equal to whatever is the nums 1, because length of both of them is same, so we can write it like this. Now we're gonna come here and L plus plus. This would be the start point of our cut, because we are trying all the cuts here. Now what would be the end point of it? For int r equal to what? 0? No, it should be L, right? Because end should be at least L, right? And r is less than, again this also can go up to n, and r plus plus. So these are the points where we can make a cut over it, right? So what we will do here is, let's say we are calling it list of integer cut. Let's say I'm calling it cut. So this cut would be what? This cut would be whatever we have popped out here. Okay, so let's take this popped out thing also. So this is al, right? So we can write al dot sublist. We have a method called sublist, so we will use that sublist method. And where we are starting at L and we are ending at R, right? So this would be our the cut which we have made. Now you guys know one more thing is like if we make it cut, we would be having left part and right part as well. So we can if we remove this cut, we would be having the left part and right part. So if we merge them, that would be our after cut value. Like in this case, when we removed this 3 6, we had the 1 2 4 5, means the left part and right part. So how we can merge that? We can merge it like this. So let's say I'm making a new list called we can call it combined. Okay, so let me call it comb. Okay, comb equal to what? It would be al dot sublist of left part. So what is the left part? Left part is anyway starting from 0 till L minus 1, right? Till L. And what would be the right part of it? So we have, this is the left part. Now in this comb itself we can add comb dot add the right part. The right part would be array al dot sublist of right part, which is starting at r plus 1, right? R plus 1 and whatever is the end of it, it would be n, right? So this would be the right part. So what we have done is basically we have added the right part into the comb, the left part. So this is the merge point here. We merged it. Now after merging this, we would be having this would be like this. After removing 3 6, this would be 1 2 4 5, and this cut is at 3 6. Now what we would be doing here is, after this operation, we would be checking that where to put. So in the comb we can put it somewhere, right? So we have to put that somewhere, because in comb we are free to add it anywhere, correct? So let's say we will do one thing. For int j equal to, let's say we are taking j. Are we using somewhere I? No, we are not using. So int I equal to 0 to I less than whatever is the size of this comb. So comb dot size and I plus plus. Now what we would do is we would be trying to implement it everywhere, right? We are trying to put it all the locations. Okay, so what we're gonna do here is we will be checking at what all places we can add it, means this cut part. Now you guys can see that we have got this comb, right, and we have got this cut. Now this cut should be implemented anywhere. Let's say at any I, if we are implementing this cut, we are putting this cut basically just like this. We had, like, after removing 3 6 we found 1 2 4 5, right? This would be our comb. Now this 4 5 1 2 4 5, now this 3 6, the cut part, can we put it, we can put it here, we can put it here, we can put anywhere, right? So that part we are doing in this case, right? So let me complete this code. Now what we're gonna do here is let's say we are calling it array list. You'll call the list of integer because we're gonna make a new one, right? So it would be, let's say we call it new list. This new list, initially it would be just like array list of integer, nothing much here. It would be like this. Now what we're gonna do is, if we are making a cut at ith, so that would be the first part. So what we're gonna do is new list dot add, and whatever is the combo, right? Our combo is the list, so comb, comb 0 to I minus 1, that would be the one part, 0 to I basically. Yeah, so that would be the first part. Now in this new list itself we would be also adding our cut, right? So what we're gonna do is new list dot add whatever cut we had, right? This is our cut here, we already parked here, so we added this cut head here. Now whatever is the length of it, remaining part, so remaining part where it would be, we have added 0 to I, okay, and from I plus 1 till end, till comb dot size, we would be having the remaining part, so we would add this also here. So new list of dot add, and whatever is the comb we have, so we would be writing it comb dot sublist of what, comb dot sublist of we started from I plus 1 and till whatever is the size of it. So let's say I'm calling it comb dot size, right? So comb dot size, this would be, we are adding now, we have made this cut at ith location, right? So now after doing this, here also we have to make comb dot sublist, sublist. Okay, so now we have made the, we have inserted the cut at ith location, right? So this is the first part, and this is the cut which we have added, and this is the remaining part of this comb. Now we have to check that hey, have we already checked it? So we will check that if set dot contains this this thing, right? If it already contains this new list, then there is no point, we have to continue, because we don't want to do unnecessarily the recomputation which is already processed, right? So in this case what we're gonna do, we are making continue. Otherwise, if it is not seen, then we are adding this set dot add, whatever new list we have found, we are adding it into this set, and then we would be adding this into the queue as well, right? So queue dot add new list, right? So we are adding all of them here, and once we are coming out of it, out this for loop, right? So this is still here. Now all the cut we have made is, that would be happening in the same step, right? We are just making the at what position, all the remaining all the positions we are trying, but that in the whatever step we have found. So now here what we're gonna do is, we will do step plus plus, okay? So now you guys can see here one thing, that we started for this L and R, right? So, but we were trying in the given step everywhere this L and R, that okay, if I make this L and this R, this L and this R, so this is happening in one step only, and next step would be started in the, when we are coming to again here, right? Everywhere when we are taking this size thing, so wherever this while loop we have, at that while loop we have to make our this thing, so it would be somewhere here, step plus plus, right? So we will make it step plus plus like this, okay? And finally we would be returning here our this thing, return whatever is the step we have. Now one more thing is, yeah, this would be our return step. So let me try, let us see what happens. If there is some issue, we would be fixing it together. Okay, so there is a integer new list is equal to new. Oh, I have to put new here. So where is that, where is that? Let me come here. Okay, we forgot to put the new here, so let's put new here. Let me try it now. Okay, let me correct these. So these are, there are some compilation error here, that if it is already seen in the set, we are continuing, otherwise we are adding it into the list, and we are adding into the set as well as we are adding into the queue. Now we would be running this. Okay, so anyway we are increasing the step every time, we are returning it -1. Let me run it. So let us see what it gives. Okay, wrong output. Okay, we missed one thing, right? The key thing we missed here, that whenever we are polling thing, we are also looking that, hey, is it matching? So what we're gonna do here is it equal to target? So if target equals to this whatever AL we are getting, okay, so in that case what will happen, we have immediately got the we will make it return step, whatever step value has, right? So otherwise we are going till end, and if here also we are anyway making a return -1, which is not a reachable code, because anyway it is given that all the numbers are there guaranteed in the both arrays. So definitely it would be, but anyway we have to put return -1 as well here. So now let me try to execute this. Okay, I am running the code. So yeah, so let me try to submit it. Let us see what happens. Yes, it is accepted. So guys, here one thing is like, how do we come to this approach that we should go in brute force? Because usually what happens, even we get a brute force approach, we always think that there could be some better solution. Then how we can trust that we should go into this solution? So here the problem is, if we look at the constraints, this is only 6. This gives an indication that yes, if we go with the brute force, it would be working. We tried in other ways also, they were not, there was the issue of the correctness of the code. So in that case we finally came to this intuition that okay, this because of 6 we can use the brute force. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.